Hello and welcome you all to this video. In today's lessons we are going to divide a segment in proportional parts. So this kind of division is not in equal parts but in proportional parts, and proportions could be related to numbers, to quantities, or could be related to other segments, other distances. Okay? So imagine we are going to divide a segment. It doesn't matter if you know the length or the length is in the drawing. This is segment AB. And we are going to divide it in proportional parts so that we are going to divide it in two parts, so then one part is double the other, or which will be the same, one part is half the other. Okay, two parts but not equal. What we are going to do is based on the Thales theorem, which is very known for proportions in geometry. We are going to use segment AB as one of the lines, and starting in one edge, for example in A, we are going to draw an auxiliary line. This auxiliary line should be long enough, okay, for our dimensions, and as we want two parts, one is half the other or one is double the other, in this line what we need are two measurements. One of them is going to be half the other, that's all. So imagine I use this distance, which can be whatever, so maybe with the compass. With the compass, I draw one segment, and the next segment needs to be double this one. So with the compass, now starting in this point, I draw one more equal segment, and then starting in this point, I draw one more equal segment. So what I have now is segment A, which will be that, and this segment will be 2 times A. Okay, so one of them is half the other. Okay, using the end of the last segment, I'm going to relate those segments here in my auxiliary line with this segment on the exercise. So I draw a line from this point, maybe I can name it like C. I draw a line from C to B. Okay, and this line is gonna be my reference. I'm gonna draw a parallel line to this from point D, which will be this one. This line in red is parallel to the other one. So what I get finally is segment AB divided in two segments. The first one, this one, is half the other. Okay, I don't know the length of segment AB, but now I have two segments, one of them is half the other. If I want to name the answer, maybe I could name this with the letter E. Okay, so AE is the same as segment EB is half the dimension of segment EB. So that's all. I hope you understood this video. If you want to check this with another example, what can we do is to divide a segment AB in 3 parts, not equal parts, and they are going to be proportional to segment A, B, and C. We don't know the length of segments A, B, and C, but we know that the last one is the longest, the first one is like in the middle. So using one edge of the segment AB, I draw an auxiliary line, and in this auxiliary line, I'm going to copy A, B, and C. The order is not important. So using the compass, starting here and taking this distance, I copy starting in A, segment A also. Now I take this measure of segment B and I copy it next to segment A, so this is going to be B, and then I take this distance with the compass and starting here, I'm going to place segment C. Now I'm going to relate those segments with this segment on the exercise. So I draw a line from the last point, which can be, I don't know, C, to the edge of segment AB, and I'm going to draw parallel lines from this point and from this point. What I get now is segment AB divided in 3 parts. I don't know the length. Mathematically we can compare. Those 3 parts are proportional to these 3 segments, okay? And that's all. Any other proportions could be done by using the auxiliary line as completing those proportions, and then using the Thales theorem, okay, so using this line to relate that with the segment we knew before. Thank you for your attention. I hope to see you in the next video. Bye bye.